Alex, I spent 3 hours yesterday trying to weld a simple hexagonal frame for a coffee table base, just 6 pieces of mitered tubing. By the time I finished the last tack weld, the whole thing looked like a Pringles chip. It had twisted so far out of square, I could have used it as a propeller for a small aircraft.
A propeller? I thought you were the measure twice, cut once, weld once guy. What happened to that legendary Tiger precision?
Precision is a fickle mistress when you involve heat. I got cocky. I thought I could just hand clamp it to the table and fly by the seat of my pants, but metal is alive. You hit it with several thousand degrees of arc, and it starts pulling and yawning like it's waking up from a nap. I forgot the golden rule. If you want it to stay put, you have to build a cage for it.
And that brings us to today's deep dive. We're talking about the unsung heroes of the shop, jigs and fixtures. Specifically, how to build them so your projects actually end up the shape you intended, rather than looking like modern art accidents. To start us off, let's clear up the lingo. I see people use jig and fixture like they're the same thing, but they're not, right?
It's a subtle distinction, but a big one for your workflow. Think of a jig as a guide. It tells the tool where to go. If you have a plate with holes drilled in it that you use to guide your drill bit, that's a jig. A fixture, on the other hand, is all about the work holding. It doesn't guide the tool, it just grips the workpiece in a specific orientation and refuses to let go. In welding, we're mostly talking about fixtures. We're building a rigid skeleton to hold our parts while we fuse them.
So, when you were making your propeller table yesterday, you needed a fixture, something to keep those 6 pieces from dancing around.
Exactly. And the trick with welding fixtures is that they have to be smarter than woodworking jigs. In woodworking, a shop scrap and some wood glue make a great jig. In welding, your fixture has to survive heat, allow for ground clamps, and this is the part that usually bites me, it has to let the part out once it's finished.
Oh no, did you weld the table to the fixture?
Maybe it's a rite of passage. You build this beautiful, elaborate steel bracket to hold your tubes, you weld the tubes perfectly, and then you realize you've trapped your workpiece inside the fixture like a ship in a bottle. I once had to cut a $50 fixture apart with a plasma cutter because I didn't leave a relief gap for the weld bead expansion.
That's a heavy price for a lesson. But you've been doing something lately that seems a bit counterintuitive. I've seen you at the 3D printer making parts for the welding bench. Isn't plastic and a 4,000-degree arc a recipe for a very expensive puddle?
It sounds like a disaster, doesn't it? But 3D printing, specifically SLA resin printing, has changed how I approach the fit-up phase. Look, if I'm doing a heavy structural weld, I'm using steel fixtures. But for the design phase, or for holding parts in a very specific orientation while I tack them, these high-temp resins are absolute magic.
High-temp resin? Like the stuff from the Formlabs notes you were obsessing over?
Precisely. You can print a fixture that would take a machinist 8 hours to mill out of aluminum. These resins can handle some serious thermal stress. The beauty is that I can design a complex organic shape in CAD that fits the exact contour of a motorcycle manifold or a custom bicycle frame, print it, and snap my parts right into it.
But surely you can't weld right next to it.
You have to be tactical. I use the 3D printed fixtures for the surgical stage. I'll clip the parts in, hit them with a tiny, precise TIG tack, just enough to freeze the geometry, and then I pop the piece out of the resin fixture to do the heavy beads on the bench. It's like having a second pair of hands that never gets tired and has perfect spatial awareness.
Okay, I can see the appeal for the tacking stage. But for the folks listening who don't have a 3D printer sitting next to their anvil, what are the fundamentals of a good, old-fashioned, built-from-scrap welding fixture?
It starts with your base. You need a datuming surface. If your base isn't flat, nothing else will be. I like to use a heavy, thick wall channel or a ground steel plate. From there, it's about the 3-point rule. To define a plane in space, you only need 3 points of contact. If you try to support a piece of tubing with a long, flat bar, any tiny bit of grit or a burr will throw the whole thing off. But if it sits on 3 distinct bolts or pins, it's solid every time.
So less is more? You're saying don't overcomplicate the contact points.
Exactly. Use adjustable stops. Bolts with jam nuts are the poor man's best friend. You can fine-tune the height and position until the piece sits exactly where it needs to be. And for the love of all that is holy, leave room for your hands and the torch.
I'm guessing there was an incident involving a tight corner and a burnt glove?
I built a fixture for a go-kart frame once that was so secure, I couldn't actually get the TIG cup into the joint. I had a 300-pound jig on the table that was perfectly accurate and completely useless. You have to visualize the envelope of the welding torch. If you can't get the electrode in there at a 60-degree angle, your fixture is a paperweight.
Let's talk about heat sink, because metal doesn't just move, it sucks heat away from the weld. Does a heavy fixture mess with your penetration?
It's a double-edged sword. A massive steel fixture acts like a giant heat sponge. If you're welding thin-gauge stainless, that's actually your best friend. It draws the heat away and prevents the metal from warping or blowing through. But if you're trying to weld a thick plate and your fixture is sucking all the energy out of the arc, you'll get a cold, weak weld. That's another reason I've been leaning into those 3D printed resin blocks for certain jobs. They're thermal insulators. All the heat stays in the metal where it belongs.
So the material of the fixture itself is a tool. Steel for heat soaking, resins or ceramics for heat retention.
You're catching on. It's about controlling the environment. You're the boss of that arc. But the fixture is the manager of the leftovers.
You mentioned weld bead expansion earlier. That sounds like one of those things that seems small until it ruins your whole day. How do you account for that when you're building these cages?
Think of a weld like a living thing. When it's molten, it's at its largest volume. As it cools, it shrinks. And it doesn't just shrink, it pulls. If you have a T-joint, the weld will pull the upright piece toward the side you're welding on. If your fixture is too rigid, if it doesn't allow for that microscopic movement, the internal stresses will either crack your weld or bend your fixture.
So you want it tight, but not too tight? That sounds like a bit of a localized paradox.
It's a dance. I like to build pre-bend into my fixtures. If I know a weld is going to pull apart 3 degrees to the left, I'll design the fixture to hold it 3 degrees to the right. When the weld cools, it pulls the part straight into its final perfect position.
Okay, that's some next-level wizardry. How do you even calculate that? Is there a Tiger's Law of pull?
It's mostly just a history of making banana-shaped furniture. But seriously, for beginners, the best tip is to use tack and check. Don't lock everything down and weld the whole seam. Put a tiny dot of metal on one side, check for square. Put a dot on the other, check again. Your fixture should hold the parts in place, but your clamps should be removable so you can check the tension of the piece as you go.
We've talked a lot about the hardware, but what about the software side? You've been spending more time in CAD lately. Does designing the fixture digitally before you strike an arc actually save time? Or is it just more screen time for a guy who belongs in the shop?
I used to be a sketch it on the floor with soapstone kind of guy. But designing the fixture alongside the part in CAD is a game changer. It lets you find the interference. You can see where the clamp is going to hit the torch or where a support is going to block your view of the puddle. By the time I actually cut metal for the fixture, I've already failed 3 times on the screen where it doesn't cost me a nickel.
And then you can just send those complex shapes to the 3D printer.
Right, especially for those weird angles. Compound miters are the devil's work. Trying to cut a steel block to hold a tube at a 22.5 degree upward tilt and a 15 degree side swing? I'd rather wrestle a badger. But in a 3D printer, it's just another Tuesday. I can print a saddle that the tube just drops into. No measuring, no swearing, no scrap pile.
It sounds like the modern maker isn't choosing between the old ways and the new ways. You're just kit bashing them.
That's the heart of it. Use the heavy iron table for the foundation, use the precision of a printed resin block for the geometry, and use your own eyes to make sure the weld is wetting in properly.
So, what's the big takeaway for the person standing in their garage right now, looking at a pile of metal and a project that needs to stay square?
Don't trust your eyes and don't trust your clamps. Build the fixture. Even if it's just a couple of scraps of angle iron tacked to your table to create a corner, give your project a home to sit in. Metal wants to move. Your job is to give it a very firm reason to stay put.
And maybe leave a little room so you don't weld your project to the table.
Always leave an exit strategy. Every part needs a way home.
That's all for the Tiger Den today. Go build something that doesn't look like a propeller, unless, of course, you're building a propeller.
In which case, it'll probably come out perfectly square. That's just shop luck for you.